Okay, hello again, grade 11s. This is part 2 of doing the mass-to-mass stoichiometry conversion. And before you start, make sure you've accessed the mass-to-mass student guide and printed off either one copy of this or maybe a slightly modified version. But we definitely want a copy of this or one that's got these steps written in, so that's your choice. I'd prefer you kind of have this and write the steps as we go. So make sure you've got your copy. So this is going to be using the water equation with just a slightly more complicated mole-to-mole ratio. And again, it's all the same. It's just not a one-to-one ratio for the water equation. So as we go along, you can fill in your copy of the sheet. Step 1, always with any kind of stoichiometry, your first step must be to balance the equation and or to check that it's balanced. So on the other side where it says do the steps, you should write in your balanced equation for any given problem. So let's take a look at the water one that's written in already. So here is the balanced water equation. Again, when we write balanced equations, we don't put the ones in the equation. So I've just kind of floated the one up above to remind us that that's a 1. Our next step is going to be to identify our given and required. This often comes from the written problem. So you'll get used to doing this from the problem, spotting what is it they've given you and what is it they are requiring. So in this case, I'm going to give you a given of we want 250 grams of water to be produced. What is the mass of oxygen that we're going to put in? So the required, the R there, is our mass of oxygen. That's what we've got to find out. So what mass produces 250 grams? Step 3, recall your known values. This is really important and one that students often forget. And the reason that step has to be in there as a reminder is because they don't often give you things like the molar mass. You have to know you can go and get that information off the periodic table. They don't give you Avogadro's number. We're not going to need it in a mass-to-mass calculation, but that's something you should just get in the habit now of writing in as part of step 3 before you attempt doing any solving of the equation. All right, let's take a look. We can get our molar masses. All right, so our molar mass of the given. Now, some people will simply write in whatever our given is. They would write molar mass and they write a little subscript H2O. That's completely fine. For this, I'm just reminding you that it is our given. So the molar mass of our given is 18.02 grams per mole. You get that again by doing the molar mass, which was covered earlier. The molar mass of oxygen, remember, if it just says oxygen, if it's written out and it doesn't say O2, oxygen is one of the Hofbrinkels, so it comes as O2, so we need 32 grams per mole for oxygen, and then write down Avogadro's number, 6.02 times 10 to the 23 particles per mole. We're not going to need it for a mass-to-mass, but just get in the habit of writing it down, so if you do need it, you remember that that's something that you know. All right, so let's just get started doing what we did before. So as we go, write in your steps, right, and follow along. You can pause the video pretty easily. So our first step, right, after we've basically done these setup steps, our first step of really solving it is this step 4. On yours, you're going to get in the habit of starting to write out the step. Please start learning to just write it out. It reminds you of what exactly you need to be doing. The first thing you need to do is take whatever you're given and turn it into moles. So in this case, we're working from mass and getting to moles. So just like before, we've got to take the mass we were given. This is our 250 grams of the water coming down from up here, dividing it by the molar mass, something that we know from the periodic table. Mass divided by molar mass is going to give us 14 moles. We're just kind of working with our significant digits here. So the 250 just has 2 significant digits since we don't have a decimal. So 14 moles of water. That's our step 4, done. We've got our 14 moles of water. Now what do we need? Well, we've got to get to the mass of oxygen. So we're working backwards in this case, from the product to the reactant. How much reactant did we have to put in? Now we've come to that heart again of the equation. So step 5, finding the moles of required. And we do that by taking the moles of the given that we've figured out and multiplying it by the molar ratio that comes from our balanced equation. So we've got 1 mole of oxygen, and that's the required, so that goes on top, to 2 moles of water, the H2O, and that's our given, so that goes on the bottom because we've just figured out 14 moles of water. So the moles of water and the moles of water cancels out, leaving us with a value of the moles of oxygen. So 14 times 1 divided by 2, pretty simple, you end up with 7 moles. And again, it doesn't matter how complicated this is, and it doesn't get too complicated in grade 11 chemistry, and they're always whole numbers because it's coming from a balanced chemical equation. So it's always just one number times another divided by a third. Simple as that, doesn't really matter. Just make sure you get your given and required around the right way. Okay, required on top, given on the bottom. Now we've got our 7 moles of oxygen. Perfect, so we're feeling pretty good. We've figured out the moles of our required. At this point, it's really important, as you carry on in the stoichiometry, to go back to the equation, and hopefully you've written out your steps really clearly and you've pulled the information correctly from the written question. What is it the question asked? So let's go back. We needed to find the mass of oxygen. All right, so we're not done. If they'd asked for the moles of oxygen, we'd be done, but we're not done. So third step is to change your required from moles, which we've determined from the balanced chemical equation, to what was required. In this case, they've required mass. We want the mass of oxygen. So to get that, we are now working on the required side of our little map here. That means for molar mass, it must be the molar mass of the required. And again, that's where students can get a little mixed up, is confusing which molar mass to use where. That's why it's important to start with following this map until you're really good and comfortable at all the stoichiometry. So we've got our moles of our required is 7 times our molar mass, which we get from our step 3 up here, is 32 grams per mole. Mole over mole cancels out, and you're left with the required unit, which is grams. So perfect, we've done this calculation correctly, we've set it up correctly because we're being left with the grams. So 7 times 32 gives us our 224 grams of oxygen. And a good final step, which will get looked for as you continue on, will be to do a nice little therefore statement. So therefore, 250 grams of water can be produced from 224 grams of oxygen gas. And that's all there is to that one. So carry on. Please make sure that you use this, all right? And you can simply have it up and follow the steps on paper, making sure you know where you are. But I would really suggest that you just work on this in pencil and maybe take photos or print off a couple of copies. You can make it print so it only takes up a small amount of the paper if you like, so you can have a few of these on the page. But I really advise that you stick with this and start maybe with the one that has the steps written in for you, and you simply do the steps. And then after a couple of problems, start with this one and start writing out your steps first and then doing them. If you do maybe 5 to 10 problems with this organizer and 3 or 4 of them you're writing out the steps first before you do it, after that you're probably going to be fairly confident in doing the whole problem without an organizer like this to help you. All right, and these are just your little guides to remember your balancing. You were looking for in the equation you're given and required, and then you were thinking about the known values you already know, remembering those known values. All right, so attempt some mass to mass problems at this point using the organizers.